Okay, today we are going to prove the constant multiple rule, which you see up here in the top left corner. It's basically just saying that the derivative of a constant times a function of x with respect to x is the constant times the derivative of the function of x with respect to x. So as you can see over here, it basically means we can pull that constant out. So to prove this, what we need to do is we need to plug this right here on the left side, c times f of x, into our differentiation formula, our original differentiation formula, which is the limit of h approaching 0 of f of x plus h minus f of x over h is the derivative of f of x, which is f prime of x. So what we're going to do, we're just going to plug it in. We're just going to plug it in. C times f of x is limit as h approaches 0, of c times f of x plus h minus c times f of x over h. Now what do we do? Well, we can factor out the c. So we're just going to factor out that c. So this is going to become limit as h approaches 0 of c times f of x plus h minus f of x over h. And this c is actually factored out of the entire thing. It's the same thing if you write it on top, but this just makes a little bit clearer what's happening. Okay, now we can just factor c out in front of the limit because c is not dependent on h. So this becomes c times the limit as h approaches 0 of f of x plus h minus f of x over h. Well, now what do we have here? What we have right here is just the derivative of f of x. This is just f of x prime. And that proves, actually, that the constant multiple rule is true because our end solution is c times f prime of x, and that equals c times d by dx of f of x, and that is what we have on here on the right side. So we have proven that the constant times a function prime is the constant times the function prime.